Good morning. Welcome to my show, Walking on the Cloud with Marco. Today we're driving on the cloud because I need to get some supplies from the store, and this is the only time I'm gonna be able to talk without distractions. As some of you might know or might not know, I have two young kids and they are a hassle, and trying to work and keeping them alive is a challenge for both me and my wife. So it's hard to take time out of our daily schedules to get these videos done, right? So I'm going to take this opportunity. I have a short drive ahead, and I'm going to talk a little bit about what's important for challenge number 2. So today we're going to discuss what happened in the first series. All right, so in challenge number 1, I asked everybody to complete the answer to the challenge, and of course the question was, you got an EC2 instance, you need the IP address, a public IP address for that instance, and you need to feed that information into a custom DNS record on Route 53. So the solution, there are many solutions, but the solution would be, you either pick up the public IP address from the metadata. So the instance metadata is where you store information, where AWS stores information about your instance and makes it accessible to your instance from inside the operating system. Things like the instance identifier, the public IP address, the public host name, all kinds of other stuff, like information that essentially wouldn't be available within the operating system because the operating system has no connection to AWS. So instance metadata, very useful when you're automating things, right? The other way to pull your public IP address is straight out of, another public IP address service. You just go somewhere on the internet, like ipinfo.com, and you pull the information out of that through command line, which is essentially very simple also. Both of those options are completely valid, and there's probably other options that I'm not even thinking about right now, but getting your public IP address through a command line isn't that difficult. Second step is, what you'll need to do with that public IP address, you'll need to feed it into an A record JSON configuration, right? So what you need to do is you need to put that IP address into a resource record file, and in that resource record file you would essentially add this IP address. I usually put a placeholder like 1.2.3.4, and then I do a command where I take the output of the previous command, like the output of the command that looks up in the metadata. So basically you just do curl or whatever wget, it can pull that information for you, and that output then needs to go into this file. So you just do a search and replace. You search for, you export the IP address as a variable, and then you search for 1.2.3.4 and replace that in your file with the variable, like $IP address, whatever, right? That could be your thing. And I will show this on the console, how you can do this easily, and I'll give the whole script of how this can easily be done. Once you've got that JSON file, just JSON config file, what you're going to do is you're just going to run an AWS Route 53 command, a CLI command, to update that A record. So let's say you've got your, I don't know, my EC2 server.aws.yourdomain.com, right? It's a typical structure I would want to use. So the idea behind doing a subdomain for .aws.yourdomain.com is, that those servers are in AWS. You can also do .gcp.yourdomain.com. You know exactly where those servers are just by looking at that public DNS name, right? And then .azure.yourdomain.com, .ibm.yourdomain.com, .alibaba.yourdomain.com, and rack space and OpenStack or whatever you are using in your environment, you can easily structure your DNS setup like that. So basically what you do is then run that command line input, which will replace the IP address. So that's the solution to challenge number 1. All right, so why would you want to do that? Well, this is something that you could probably put in like a Bastion host, where you've got a host that is a barrier to entry to your environment, right? So for example, you're managing a fleet of Linux servers, but you don't want those Linux servers exposed on the internet, so you don't open SSH connections to those Linux servers. So what you do is you create a Bastion host in between the internet. The Bastion host has a public IP address and is also connected to the same VPC that your Linux servers are, and essentially that gives you the ability to hop into the Bastion host and then run SSH commands from the Bastion host itself, right? And you can have very stringent logging and very high security on that one host, because you centrally manage it, instead of having to manage that stringent security and that all those features that essentially limit the traffic to your environment on your fleet of servers, right? So that's a really good idea. You can also structure your security groups by allowing your Bastion host to only be accessed from your own static IP address or whatever access environment you have. And then of course, on the other hand, you can allow access to SSH only from the in the fleets of servers, access to SSH only from the security group that is associated with the Bastion host. Now, if your Bastion host goes down, no problem, right? Because you got self-registering DNS, like for example, bastion.aws.com. Your Bastion host goes down, you can have it self-recover. You just look in the memory, you look, sorry, not in the memory, in the CloudWatch environment, you look at the events for this instance, right? And if this instance goes down, you can just have a trigger for a Lambda function that will spin up a new instance of that Bastion host from that image that you want to have, right? And that's the idea. You want to keep your Bastion host stateless, of course, because it's only like a hop host where you just hop in and then run commands against. So you'll pre-configure an AMI, you'll secure it, you'll patch it, and then you post it, right? You could also have other ways of doing things. You can put this Bastion host into an auto-scaling group, right? And set a minimum of 1 and a maximum of 1. That means that the auto-scaling group will try to maintain that instance over time. So basically, if that instance goes down, the auto-scaling group will replace that instance, right? So that's a simple way of doing high availability in AWS for one single instance that you have, right? And because I'm tying it to a public IP address that changes if that machine gets shut down or if that machine gets replaced, I'm using the script that I said before, that I set up before, to essentially self-update that script. Now, how do you self-update? Where do you get the permissions? Well, what you want to do is you want to make sure that the communication to Route 53 is as secure as possible. So this is the challenge for you, is to find the most secure way to update your Route 53 record with that public IP address information inside of the environment, right? So we're talking about, you need to push some scripts, like we said before, those scripts that pick up the IP address and put it into the configuration file, into the JSON file that you're going to push into your AWS Route 53 command. And once you got that done, you need to figure out how to securely authenticate to Route 53 and have that instance automatically update that Route 53 record. Now here, there are multiple options again, right? And I will actually be rating any responses on the level of security. So try to make it as secure as possible. Make sure that you're adding security in at every level. And of course, that is it for this episode of Walking on the Cloud, Driving on the Cloud. My name's Marco, and I will see you in the next one. And of course, forgot to say, as I said in the beginning, this time the challenge has a double prize of 2 $25 Amazon.com coupons. And of course, this prize will be rolling into the next challenge if nobody gets an answer posted on the video itself. So that is it for you, from me, for you, to you, for me, whoever is here, listen to me. Anyway, thank you very much for watching this video until the end, and good luck with the challenge, and I will see you next time in my challenge series that is right now connected to AWS, but will soon be doing other cloud stuff. We'll be doing other features from other environments. Thank you very much for being with me for the 10th time already, and I will see you on the next session of Walking on the Cloud with Marco. Goodbye.